All right, let's get started. We are here for our fourth and final broadcast of the 2021 Humulus U live broadcast series. We are today coming at you live from our state-of-the-art facility in Yakima Valley, our BSG Hop Facility, with Shane Dale, our Senior Director of Hop Operations, and you can see Shane's out there walking the grounds. Just wanted to first welcome everyone and remind everyone that we will be recording this and sharing it afterwards, but all of our previous HUMU broadcasts can be found on our YouTube channel at BSG Craft. With that, Shane, how are you doing over there?
Good. It's a beautiful day. As everybody can see behind me, the smoke is cleared and it's cool, it's sunny. Some hops on the ground that I'll be showing you later that we're bringing in. This is the tail end of harvest. So we're just trying to wrap things up and get to processing some pellets.
Well, I will let you get to it. I'm going to turn off my camera and let them see what they are here to see, which is really
Sure.
ability. So thanks so much. I'll jump back on. And also for the audience members, as you have questions for Shane throughout this, just type them into the Q&A widget at the bottom of your screen, and we will reserve some time at the end for you to ask Shane some questions. Thank you.
All right, well, I am starting outside, kind of the entrance to our facility. We're very local. We're actually just south of the Yakima, city of Yakima, just north of a small city called Wapato. This is a very central location. It's right in the probably evenly in between all of the hop growers. So it's a nice access for them when they're delivering. This facility in 2014, we purchased this facility and I was hired to help develop it, put in a hop processing line. And then I was lucky enough to stay on and manage it. So this is just kind of the entry. You can look in there. You can see we just got a load of 2021 New Zealand hops. So that's what's coming in right now as far as finished goods. Later on, I'll go out and show you the bales. As you can see over here, a little tent covering. That's our entrance for our customers that are coming to select. Got a nice little beer garden out there and an entry into our tap room. And if we have time, we'll probably finish up in the tap room and kind of show you what goes on in there. But anyway, we're going to head through, enter into the office. I apologize if I make anybody car sick with the moving of the camera. And with COVID restrictions, of course, we have to have passwords to get in. And coming into the office, the first thing I'm going to do the hop lab is something you don't always get to see, but I let them know I'd be coming in for a couple minutes just to kind of show what our abilities are. So this is our hop lab. It's not huge or real fancy, but we keep it clean. We've got a back room back here. I call it the grinding room, but you can see the hops that we've been sampling harvest all lined up, ready to start running analysis on. We've also got full capabilities on oils. And so this is our line of distillation units. Once we start pelleting the cones into hop pellets, we're going to run those samples for total oils and an oil breakdown. Coming back out here into the clean room, you're going to see all of our fancy equipment. And I hope none of the questions later on are about the lab, because the 3 or 4 big words I'm going to say here in a minute is about all I know. But right here is our UV spectrometer. That's our basic BVs. That's our quickest way to get the alpha beta and calculate the HSI on cone hops and pellets. And then once we do the distillation in that back room, we can bring it over here and put it on our gas chromatograph. And that's going to break down those oils and show us exactly what that total oil is made up of, and all the different oils and those levels. Over here, we have a high pressure liquid chromatography machine. And this does things a little the same, a little bit different. But one of the things it will do is actually decipher and calculate those humulones and cohumulones as well. So like I said, don't ask me too many questions about the lab. I just wanted everybody to see that we do have a full hop lab. We do have the capabilities, you know, to put full analysis on our certificates of analysis. And as we head back down, like I mentioned before, in 2014, this facility was purchased. Before we purchased it, it was an apple packing facility. And if you think about the Yakima Valley, apples are a big thing here, even bigger than hops, unfortunately. But this facility, this is our production room. And at one time before we bought it, it was full of sorting lines where they would put the apples on, sort them to grades and sizes. That fruit company has since gone to bigger and better buildings. They left us a shell that was pretty run down. And so our first thing was to really come in here and gut the place. We did that by covering up all the floor drains. We want a really dry facility here. Added metal liners to the wall for more of a food grade atmosphere. Polished the floors, as you see, they're nice and shiny and smooth. Improve the lighting. That was a big thing, you know, for people to feel comfortable. We want that great lighting. And then the next step was to start installing all of this equipment on this processing line you see here. Quite a process. Just in general, the processing line was functional in November of 2014. November is not an ideal time for a startup. Startup is usually in October for processing. But you know, we had rushed it to get it ready for that season. So we still had time to process about a third of our crop. This crop is bales that we contract with growers. We don't, basically anything we buy, we have contracted with growers. Some of the misconceptions were, BSG just buys and sells. Well, guess what? We're in cahoots with those growers out there. We're able to choose the ones that give us the best quality and contract with them. We're going to get on to just the process. I'm kind of going to walk it through from beginning to end. As you see, there's a door back here at the end of this conveyor, and that door on the other side is cold storage. And so this conveyor actually goes out into cold storage, and it's got about another 100 feet out there. And that's where we're going to stage our hop bales when they're ready to process. What that does, that allows those hop bales to stay outside and cool until they come into the room. The other thing, getting those bales in here by conveyor, this entire area is now forklift free, which is just kind of a safety concern we had. When you get into enclosed areas, people on the ground, forklifts traveling. So we put in this automation on the front end. Basically what the bale loader will do is over there on that light pole, he's going to hit that green button and that door is going to open. Actually, there's a high-speed door on the other side of it. And a stack of bales is going to come through on this conveyor. And that bale loader is going to grab this jib crane, which is pneumatically operated. And you can see the claws on it. He's going to grab one bale at a time. And then he's going to bring that over and he's going to set it over this initial conveyor. And this is where he's going to cut the ends of the polypropylene off of the bale. He's going to do one slit right down the bottom of it. And when he does that, that bale basically drops down onto the table. And then it's already, the claws are already in the polypropylene wrap. So as he lifts it up, it just pulls that wrap right off of it. And you've got a bale slowly going up into this conveyor at about 2.5 feet a minute. So when we're running, you'll see a line of bales and you can kind of see the wear marks on that upper belt, where everything feeds down the middle, but you'll see a line of 5 or 6 bales on this conveyor going into the system. So this first contraption here is the Bale Breaker. The Bale Breaker its purpose is to do just that, to break that bale up, get those hop cones loose again, because they're compressed in that bale. Once those hop cones are loose, then we're able to bring them out. And I'm going to try and point at stuff, and I'll probably run my head into stuff because I'll be looking at the phone. But when those hop bales are loosened up in here with some big teeth, those hop cones then fall down, and this auger takes them either this way or to the other side, depending on which line we run. And we do have 2 lines here, and I'll explain why we have that later. But as those loose hops come out to the end of the conveyor, they drop down here. Now, remember, they're loose. And this line, as you see, it sweeps up and into the next component. That's driven by air. We've got an air system moving these hops. What that allows us to do, as these hop cones fall down and get swept up, anything, any foreign materials, dirt clods, rocks, cell phones, glasses, whatever it be, inside of those hop bales that may get there, they're actually going to be too heavy and too dense to travel up. So they're going to come down here in this debris trap. Every once in a while, the operator will come over and he'll kick that door open, see what kind of goodies he's got. It is very normal to get debris. We are receiving these from an agricultural farmer, an operation that is maybe not as clean as this room, but that's agriculture. And you're going to end up with, maybe some small rocks, some dirt clods, some nuts and bolts, and then those odds and ends that are always fascinating to find. But that's one way we get rid of that. As those hops sweep up into this big turn up top, they come down into this next component called the hammer mill. You can see we have 2 of them, 2 lines. This hammer mill's job is to take that hop cones and pulverize them into a powder. You can see I left the hammer mill open so you can kind of see it. I'm going to try and get close here. This is a screen that they put up there. This is one of our larger screens, and behind it is a series of hammers. That's going to be kind of hard to see, but as this thing is turning, those hammers with centrifugal force come out, and that is what is beating those hop cones into a powder. Now we know that anytime you beat up a hop, crush it, pulverize it, you're actually doing damage to that hop. And so we are going to do as little grinding as we have to in order to get the grind we want that will give us the perfect pellet. As you can see down here, there's a little sight or a little sample collection plate. We open as soon as we start running. Basically, that's just air and hops going through there. So you can stick your hand down in there, get a handful of hop powder. And that's how you visually can evaluate that hop powder and just see how you're doing on the grinding. Once that hop powder is fine enough, it comes out of that screen, it's going to drop down and it's going to come up this next sweep. Again, the air is pulling it through, over, and then these are cyclones with airlocks below them. Now, the purpose of a cyclone is to basically use centrifugal force to push the solid material to the outside and then exhaust that air, clean air, up through the middle and through the exhaust. That hot material, which is what's going to be in there for us, is now going to settle to the bottom of it. The airlock at the bottom is much like a vacuum cleaner has to have an airlock or else you're just blowing hops through. But it's going to separate that material and dump it into this large blend tank without letting any air through. So you can still maintain that vacuum on that system. Once that hot powder goes into this tank, that's where we're going to mix it. And this is kind of where I'm going to get into 2 lines. So one of the reasons we have 2 lines here, and I don't know if you can see that other tank back there, twofold. One, when these screens that I showed you earlier on the hammer mill get clogged up, we call it blinded over, there's no airflow through it after that. So we have to shut that machine down, and it takes a good 15 minutes for that large 150 horse motor to wind down, get in there, remove your screens, clean them, put them back in, and start it back up. Well, in 15 minutes, that's about a half a tank that we've ran. And if that tank was only half full, then we're starting to starve ourselves for powder. One thing you don't want to do is stop running hot. Once you start, you want to keep going until the end of that production run. We'll get into that more later with the quality. But what this second line allows me to do in that scenario is I can shut down with a touch of a button. We have a touch screen panels here. You can see everything's red because we're not running right now. And it'll show you the different lines. And then you can go to the different control centers, and I can control my hammer mills, or I can go to the air system and I can control the air. But we've also got a one button here we hit, and it just automatically, things start shutting down on one line and start up on the other line, and it switches over. So then we could be running powder into that second tank and never starve our pellet mill for powder. You see in the back, we do have a rack back there with extra screens on it. So we don't necessarily have to pull screens out, clean them, and put them back on. We can pull them out, throw another set of screens on just to kind of speed up that process. Two ways we can run. And here's another reason we have two tanks, two lines. The easiest way is to run a lot. When I say lot, not a lot like a bunch, but LOT, lot of hops. For us, that's a batch. That's what comes from the grower. It's got the same grower number on it, came from the same field, obviously the same variety, and it's very consistent. Now, we're going to run that lot. If we're running it alone, we're just going to run it bale by bale until that tank is full. About 2,400 pounds is about 2/3 full, and that's where we like to maintain it. Once we get that 2,400 pounds in there, it's already mixed. It's a very efficient paddle blender. Once that last bale goes in about 5 seconds, it's thoroughly mixed with the rest. Now you've got a real homogeneous blend in there of those 12 200-pound bales or more if you're running the wolf bale, the small German style. But it's consistency. And so we know that's full. Now, if we're just running that single lot, when we're ready to run, you can see down here, there's what I call a guillotine valve, because that valve is closed here. And when it opens, kind of like a guillotine, powder comes through, and then this auger is going to take the powder further down the line. Now, once we start feeding that, if we're running the same lot for the entire run, we're just going to keep feeding bales and keep popping off that tank. So as we run 200 pounds, we're filling 200 pounds and continuously mixing as we run. But the other scenario, and why we have two lines, is called batch blending. So this is where, say we have a customer come in and they've got a large contract of a variety that can't be fulfilled with a single lot. Or they just really like two different lots and they just want to mix. And I've done blends that are 6, 7, 8 different lots into one. It's just a matter of building a recipe. Maybe it's 1 bale of this, 2 bales of that, a half a bale of something else, 4 bales and 2 bales, and all those numbers you put in, that's your recipe for one batch, 2,400 pounds or close to it. Feed those in, fill one tank. Once it's full, it's blended, we can start feeding that. Now, we don't want to top off that tank because then we're going to mess up the recipe and it's going to start becoming uneven. So that's when we switch over to the second line. And while we're emptying this first line and running pellets with it, we're going to fill that second one and just back and forth. And when this tank is empty, we hit a button, it switches over to the other tank and starts feeding. Again, no interruption in the feed of hot powder to the pellet mill. I'm going to come around here and give you a little better look at the conveyance system. I'm not actually going to get under there. I might not get back up. But over here, you can see these kind of inclined conveyors. They're covered, but there's 2 of them, 1 for each tank, and they're auger conveyors. And you know, we have a lot of sight windows here. This is a very sealed system. What we want is less opportunity for foreign matter or anything to fall in. And to do that, you have an enclosed system. You've really got to have it sealed up well. But to know what's going on, you got a lot of sight windows. And so we cut in more every year just to see different things, you know, little sight windows. another sight window. And that way we can monitor what's going on inside the machine, stuff that the computer won't necessarily pick up. So coming back, that powder is then dropped into this big white thing that we were just focused on. This is a bucket conveyor. So it's a conveyor, but it's several buckets, just back to back to back. And each one's going to be filled with powder. And it's going to transition vertical. It's going to go up to our third level, farther than we can probably see here. And it's going to go out and over and into a surge bin above the pellet mill that's over here. At that point, that powder is staged and ready to go through the pellet mill. Now, these big blue components you see over it, these are our air system filters. We have 3 systems. I'm not sure you can see that. This big one right here is the larger CFM air system. That's the one that conveys the hops from the Bale Breaker to the hammer mill to the blend tank. The 2 smaller systems, we've got one that just works our pellet cooler. So it's using that air system to cool pellets, pull ambient air up to the bottom of pellets to help cool them. And the other one is called our house dust system. Now it's hop dust, that's the only thing, but you'll see a lot of small vacuum pipes around this system. So what we've done is we've taken a look at this system, how it runs, where are the points where we might have some dust we can reclaim before it hits the ground. As we know, as soon as it hits the ground, it's no longer a food product. It's got to go in the garbage. We all know, what a pound of hops costs. So we want to collect that before it hits the ground or settles on a machine. So we've got different points that are going to pick up that dust. And what it does is it recycles it back through these filters, separates it from the air, kind of like the cyclone does, and drops it right back down into that bucket conveyor that's taking that pellet powder, or the powder for the pellets, right back up. So anything we reclaim is immediately put back into that pellet mix. One thing we have to be careful of, we cannot start the next production run, whether it be just the same variety, different lot, or even a different variety, until the pellet mill is shut down and the last of the pellets is through. The reason for that is if we're trying to fill a tank over here while we're finishing up another tank from a different run, that could cause cross-contamination. And it's just something we guarantee. We run one thing, that's all it is in there. And we do our best to make sure we don't contaminate with any of the varieties or lots. We're going to take a little walk upstairs now. I know you've seen all this bagging equipment and stuff. I'll get to that. I really like to go through the flow of the process. Up these stairs to the second level. And I'm going to explain this pellet mill the best I can. It's a little easier in person. Right now, we've got it semi-torn apart, getting ready to put a different die on. But basically, I'll step over here to get a better view of it. This is the pellet mill. This is our bread and butter right here. And you see as it extends through the roof here, it's connected to our surge bin that I mentioned. That's where the hot powder is stored. A surge bin is just that. It allows for a little buffer. So you've got about a bunch of powder up there. And as you run it, if there's inconsistencies in feeding that surge bin, it can make up for it. It's got a little buffer there. And it gives the computer time to say, hey, I'm getting a little low. I need to speed up my conveyors and bring more powder in. You can see back here, we've got other pellet dies. We have 4 different pellet dies that we use. Currently, we're using 3 of them. The difference is thickness and compression. And so this one right here is a real thick die. It's actually a 4-inch thick die. That's going to be our varieties that need more compression in order to get the same density. This die, the one that's going to go on now, is kind of a middle of the road one. It's going to run some varieties that need less compression. And one thing I'll explain right now is you see these yellow hops, not actually hops. So this is corn. And we get pallets of corn, about 1 pallet a season, that we use to prime these dies. This is a food grade corn. It's actually a brewer's corn. It's a plate corn, OIO brand or something that we get from one of our malt warehouses. But this die is going to generate a certain level of heat. It's not going to get very hot. You can still put your hand on it, but you're talking 150 degrees maybe, maybe a little hotter on the die itself. But when you stop running, if that die is full of hops, it will sit there and burn, basically. It will cook those. Well, hops have oils, and it creates a natural resin. And once that die cools off, it's like concrete inside all those little holes. And so what we do before we take a die off or before we shut down for a few days, we throw a bag of corn in it. It pushes out all of those hops and primes it with corn. And the corn itself is dry, no oils to speak of. And it basically just falls right out. When we go to start up, that big color difference is very helpful because we're going to push that corn out of the die with hops. So as we start up, we start feeding the hops in, it purges out all that corn. And we know right away when all the corn is gone, because it's bright yellow, and when the hops are coming out. So we'll get back to the actual process. So up here is an auger, a lot of augers. It's going to pull this hop powder out. It's going to come down this short chute here. And when this door is closed, this is where a chute is going to mate up to. Hops are going to go down. They're going to come through the front of this door and get pushed into the pellet mill. Now this die right here actually goes here and surrounds this assembly. And these rolls right here and right here are right up against that pellet die, the inside of the pellet die, creating pinch points. And that's where the compression takes place. So it's really a simple process. You put the hot powder in, you compress it up against the inside of this die, and eventually it starts extruding pellets. And the interesting thing, if you look at pellets, and you're probably not going to see it here, it's like a tree rings. You're going to see ring after ring after ring after ring along the length of this pellet. That's basically how many rotations it took, because every time it hits one of those rolls, there's a compression, and another small layer of hops get added to that pellet. Those are continuously extruded out as we run. The pellets that fall off, there are knives on here that will knock them off if they get too long. We don't have that issue because of our density that we shoot for. The pellets naturally fall off and they're about a 1/2 inch to 3/4 of an inch long. But they will fall down through this chute in the door and down through the floor. This hole to the right is our waste. The hole to the left is our good pellets. Basically, when we start up, we're going to throw away a couple 100 pounds of pellets, get it right. We got to purge out that last variety that was stuck in the die, or purge out that corn. And then we have to get this mill running the right amount, the right speed, which is for us pounds per hour, so that we're getting a good quality pellet out. Once that happens, we can divert it. In the bottom of the door, there's a diverter that flips over, and we'll start sending it to packaging. I'll come back to this machine a little bit later, but when I mention working on hop density and how to control it, this pinch point that's created is one of the key factors in fine tuning that. So once the pellets go down, they disappear for a second and they come right back up another smaller bucket conveyor and get put into this big square box here, which is actually the pellet cooler. Gonna squeeze in here. So this slat bed doesn't look like it's very sealed up, but that's the purpose of it. Once the hops start falling in here, you're going to get a big mound of pellets sitting here, about half full, and you've got this air being pulled out of the top. Well, the only way that air can come from is from under these slats, and the air is going to come up through this entire bed of pellets, cooling it down. Once it reaches a high level, which is actually right here, it's called a Vindicator. It's going to hit that. It's going to tell it, hey, you've got a pile of pellets in here. You're filling up, and then it's going to send a signal to the computer The computer's going to evaluate the temperatures of the pellets, make sure they are cooled off enough, and then it's going to dump them down below into the next machine I'll show you. These are actually temperature probes. There's 3 of them on the machine. That one is measuring pellet temp. You've got one up here that's measuring ambient air. You've got one in the exhaust duct that's measuring the exhaust air temperature. So we don't run very hot here. We typically run an average of about 115 degrees on our pellets as they come out of the die. That's fairly cool. We could run it cooler, but you need a certain amount of heat to really liquefy those oils to become your bonding agent, what holds that pellet together. Get above 135 degrees, you're kind of in a danger zone, one where you can start evaporating these good oils out of the hops and losing that. And after that, you're going to start burning them. You're going to get hops that actually smell like burnt rubber. And that just means that they were run way too hot. We actually have liquid nitrogen plumbed to our machine. So at startup, you may not be running as much powder at startup because you're just getting things going. Well, there's not enough material coming through that die to remove the heat. So it's heating up. So we have all these contraptions here that are reading off of a probe that's down below that's reading the pellet temperature. And it's telling these valves to open or close and put liquid nitrogen on that die to cool it down. Now, there's a lot of people out there that will say, oh, liquid nitrogen, you can't use that. It's just not right. And for a long time, I argued with that. It's not that you can't use it because it doesn't hurt anything. It's that if you are using it, you're probably doing something else wrong. And so I was real proud of this machine once we got it running. As soon as we get to production speed, the temperature of the pellets tell that valve just shut it off. We don't need it. And so when we're running, we actually don't use liquid nitrogen. It's just a startup tool for us. Head back down. There's your pellet cooler, and directly below it, I'm going to drop these pellets into a screener. It's a Slico Screener. It's real gentle. Right in the middle of it, you've got a screen that goes across with certain size holes so the pellets won't fall through. And it just gently shakes those pellets, and they'll drop in, they'll move to the outside, and they'll come around. Clean pellets will drop off down into the next conveyor. Any powder, undersized pieces that we want to recycle will drop down and get pulled up and recycled back into the mix. Those clean pellets, here's another bucket conveyor. It's going to take that up, and it's going to take it a scale over our bagger. Now the scale we use is a 14 bucket combination scale, very accurate. All of our dumps are 11 pounds. Even if we're running a 22-pound bag, which we still do for some customers, it'll just be 2 11-pound dumps. So as you see the scale here in all these buckets, pellets are going to come down from another surge bin. They're going to come out inside this cone. You have a pile of pellets here, and it's going to sift them out and vibrate them out into the different buckets a little bit at a time. Each one of these pans is a vibratory pan. And so depending on what it needs, that single pan will turn on, vibrate a few more pellets in. It'll weigh it. If it likes the weight, it'll drop it to the lower bucket and wait. The lower buckets, you got 14 of them. They're all holding a different amount of pellets, but any 4, 5, 6, 7 buckets in combination, the computer is going to figure out how best to make 11 pounds. And at that point, when it finds a solution, all those buckets that it chooses open at once, and all those pellets fall down through that tube and into the bag that it's making in the bagger. It's a very complicated machine. Thank goodness the computer does all the work, but it's very accurate. If it's clean, meaning there's not a lot of lubricant buildup on it, you're probably looking at running 100 bags, and the weight will not vary by more than 2 or 3 hundredths of a pound. Our tolerance is 11 pounds to 11.1 pounds. And so meeting that tolerance is very easy. So there's where your hops are coming down into this bagger. This is a vertical form, fill, and seal bagger. We actually make the bags as we run. They just come in a long sheet. A lot of people call these our bags foils. They're not actually foils, they're a laminate. So yeah, there is foil. There is a certain amount of aluminum in there as a barrier, but on either side, you've got polyester, nylon, and a sealant layer. All those combined produce a very, very protective pouch. The oxygen transmission rate on these bags is amazing. We found that if you've got good seals on these bags and they're stored in the cooler and out of sunlight, which is pretty easy, you can have 4, 5, 6 years of life with zero or very little degradation in your brewing values. And so that's a great improvement from about 7 years ago before we developed this material. Now everybody is using this material. There's a couple different suppliers, but basically everybody's using the same one. It's a great quality bag. You look up here, you'll see 2 hoses going in. That's our nitrogen. So that's gas nitrogen that we bleed off of our liquid tank, and that's what we use to flush. So as this bag is made, you can see those shoulders up there. The shoulder right here, that material wraps around it, and then it encircles this tube, forming tube, and creates your bag. This piece right here is doing cycles and creating your back seal, the teeth. And then these are your jaws that when they close and pinch that bag, they create a seal and then cut the bag off. And so once you have the bottom of the bag made, like this, it'll drop down. Your 11 pounds of pellets will fall down into it. It will be continuously flushing with nitrogen. Our machine actually samples that the air or the gas inside of that bag every 3 seconds, feeds back to the computer again, and lets it know if it's okay to seal up or not. So we target 1 to 2%, understanding that if you're at 1 to 2%, once you seal up that bag and put it in the cooler, those hops will actually eat up that last 1 or 2%, and it will be 0% within a few days. If we put everything at 0%, which we can do, these 11s actually run at about 0.8 to 1%. But if we put everything at 0, we're not going to know, is it 0 or is it 10 times 0, and we're just burning up nitrogen and wasting money. So we do set it at between 1 and 2%. Got a light stack up here. If it's green, it means you're below 2%. It'll close anytime. The yellow means, hey, you're between 2 and 3%, and we need a little more flush before it, and it automatically controls that. The red supposedly is, yeah, you're above 3%. I'm not going to close these jaws. I'm not going to make this bag. Honestly, I've never seen the red light come on. So the only thing that would happen is mean you've got a blockage in your nitrogen line, or you're out of nitrogen altogether, and that's kind of a no-no. It just means you shut down. So these bags are made, they're cut off, and this table, it's tilted down right now, but it's usually up. But it will drop that bag onto this conveyor. Takes that bag back under the conveyor or the bagger. This little mat here is because this is where a person stands and checks the bags. They're going to check the back seal. They're going to check the top seal and the bottom seal. That's still a manual visual operation. It has to be done on every single bag. If you do all this work for this entire machine and you have a bad seal, say some pellets got hung up there and they drop just in time for that jaws to close on them, and so now you've got pellets stuck in the seal that could compromise it. Well, all that work is for nothing because oxygen is going to seep in, and when the customer gets that bag, depending on when they get it, it's probably going to be degraded to the point where it's noticeable and could impact. So that is something that people have told me, oh, you don't need that person, we can automate that. I've never bought into it. That has to be a manual and visual operation, every single bag that goes through them. If the bag passes their inspection, it's going to come across a check layer. This is where we're actually weighing individual bags, and where we're saying, you know, it's got to be, you know, 11 pounds to 11.1 pounds. And that's carrying the weight of the bag. The bag, an 11-pound bag, weighs about 0.18 pounds. We put that in as a tare weight. So what we're weighing is only hops. I know it seems minuscule, but it's our way of being able to go to a customer and say, hey, you're buying the hops. The bag's on us, you're buying the hops. If for some reason it does not meet the weight spec, you've got a reject conveyor here that's going to kick it off. That bag may be weighed one more time just to make sure. And then if it still fails, it's going to be taken over, opened, and put back into our bucket from a pellet conveyor over there. It's going to take it right back up and make another bag with it. These 11-pound bags, it happens fast. They're usually spread out by about 6 feet on the conveyor. The machine running between 12 and 14 bags per minute. It seems fast when it's running, but then when you get farther down to the line to the pallet building, it seems like it's going slow. Anyway, these bags, once they pass the weight inspection, they're going to come up on this upper conveyor across the top. And this other machine over here is actually taking our box blanks, which are called trays, and it's folding them up, gluing them together, and pressing the new one down on the conveyor. The empty boxes come across the bottom, go into this machine called a case packer. The box is staged here. When it's ready, it moves the box up to the fill station. You'll have bags of hops coming out, and this machine will stage 2 11-pounders, settle them, drop them into the box, take 2 more, drop them over the top. That box comes to the next station over here, and you can see this big plate with these blunt nodules on every corner. That comes down, it tucks in all 4 corners, so they're not caught up in the box when it closes. And it also gently shakes that and settles that box to make sure it's all settled in there evenly. Now the box is going to come out, it's going to hit another check layer. So machines aren't perfect. There is a chance that a bag gets hung up here and you only get 3 bags in a box. Maybe the next one has 5. Well, this check layer is going to make sure that everything weighs 45.5 pounds, basically. If it's under that or over that, it's going to reject the box, and it's probably going to reject 2 boxes because one has 5 and one has 3, and then they can correct that before they put it back on the line. Then the box goes over here, a little chain transfer, moves it in the opposite direction. This is our print and apply. So we've got labels downloaded to it. It's going to label it and apply the label. Once it's got the label on it, it comes through this. It's called a Flange Sealer. It's going to glue, it's going to push the top down. It's going to glue some small flanges, fold them down on the sides or the ends of the box, and glue it together. And then the box comes out. The box we use has no tape. We changed that about 3 years ago. We went to an all glue box. Reason being, we wanted to create a stronger box. And if you tape a box, that box will still shift. But if you glue a box, it becomes more rigid. So it's better for storage when you have a pallet on top of another pallet. And it's also a tamper evident box. So a tape box, you know how you can stretch that tape, take it off, and put your poison in the hops, tape it right back up, and nobody will know. Our box, if you open it, you destroy the box. So it will tear. The only way to get it open, and you know, okay, this has possibly been tampered with. We need to take a look at it. Never happened, never will, but it's just another one of those food safety precautions. So now these boxes, full and ready to go, are coming down. They get moved over below this robot. This is a very nice robot. Shows up every day, never gets sick, and it only works about 1/4 speed of what it's capable of. It was actually designed to run a second line if you ever get to that point. But it will pick up these boxes, stack them on the pallet. Once that pallet's full, it'll go through that gate, it will open, pallet will roll through. It'll get stretch wrapped right here on the line. And then when it's done, that door, there's another high-speed door behind it. When that's open, the high-speed door comes up and the pallet goes right back into cold storage, theoretically ready to ship. Yes, we want to cool it down, give it a good cooling before it goes out the door, but it's tagged, it's got the barcodes, we're able to enter it into inventory and get it out of here when it's needed. So the entire operation, when you're running smoothly, from the time the hop bales come in on cold storage to the time they go back out into cold storage as a finished goods, about 30 minutes. So real small time frame where they are above the ideal temperature or exposed to oxygen. There's really a lot of expensive things you can do about that, but there's a lot of reasons you don't. One, if your hops are too cold and you cannot get that heat at the die, you're not going to get the bond. You're not going to get those resins to act as the glue to really stick those pellets together and hold them. So we don't want them really cool, but we do want them to go right back out into cold storage and get cooled off. So I'm going to touch on a couple of quality things here. One thing we do that, as far as I know, is still unique, although I've taught as many people as I can, other dealers, other processes, lots of customers, is measuring density and why that's important. So pellet density is how hard it's compressed. The old way, or sometimes it's still the current way of doing that, is to take a bucket. You don't even have one because you don't do it. And say that bucket or that pitcher is 1/2 of a cubic foot. They fill it with pellets, they weigh it, they times it by 2. That's how many pounds per cubic foot they have. My example to that is if your pellets are 1 inch long, they've got a lot of air space in there. You're measuring that air too, you're weighing that air. If you take every one of those pellets, break them in half, they're going to fit tighter. Now you have less volume, yet it's the exact same sample and it's the same weight. So now you just increased your density just by breaking the pellets in half, and that's not a true density. That's volumetric density. That tells you, is it going to fit in our box or not? We're not concerned with that. We built our box that will fit every variety, no matter what. We shoot for a certain density, and we're able to do every adjustment we need on the fly without shutting the machine down. So it starts back there at the hammer mill. We can go to the touch screen and we can adjust the airflow, see how fast it pulls the hops out of the hammer mill. If we're not getting a good enough grind, if it's too coarse, we can go to the air system. We can hit our fan and we can change using hertz. We can change that and say, I need to slow you down a little bit. Or we can go to the hammer mill and we can speed the hammer mill up using the same one. All on the fly, takes a few seconds, and we can make those adjustments on the fly, go take another sample, take a look at it. Now I mentioned the lineator rolls up there, those rolls that create the pinch points. That is our final adjustment for density. It will adjust 2 to 3 pounds per cubic foot solid density as needed by opening and closing that and creating a different gap between those lineator rolls and the pellet mill die. By doing that, you can push harder or softer to adjust that density. Why do we do that? We've done a lot of research, a lot of testing on different densities, how they react in the vessels. So we know that if you're putting it in a kettle, rock hard pellets or rocks themselves will eventually dissolve. But what we're looking at is dry hopping. Everything we run could be used for dry hopping. And if you've been around a while, you know if you get a super hard pellet, and there are some people that do make super hard pellets in certain varieties, you can leave them in your vessel for 2-3 days. And when you go to empty it, you've still got complete pellets coming out of that waste line. That tells me you're not getting full utilization of those hops. So we want a hop density that when you put it in the vessel, within a short amount of time, it breaks apart and you've got a hop slurry through that vessel.
Hey, Shane.
Yeah.
Sorry to interject. I just wanted to hop on because we have had several questions come in and it's about 10 minutes left in the program. Do you mind if I throw a couple questions your way?
Yeah, go ahead.
You can continue maybe in your walking tour or flip it around, whatever you.
I'm actually gonna, if we're that short on time, I'm gonna head out and see if we can see some hops being harvested while we're talking.
Excellent. All right. Well, the first question was, how do you process process customer hops or just BSG hops? As a brewer, are you able to process hops that aren't crafted or aren't contracted through BSG?
Yeah, that makes sense. So a majority of what we do is for Brewer Supply Group. We are Brewer Supply Group. So the hops are ones we contracted with growers when they can draw contract. So we will do a contract with dealers, growers, customers that have already contracted their bales. And so maybe they're not even contracted with BSG for anything. We do a case-by-case basis. We look at it and we say, okay, what do you have? What's the volume? What are the varieties? We can figure out a price, and then we can figure out logistics. And yes, we can process anybody's hops. There are some things we look at, like how does this help BSG, or as long as it's not negative for BSG, we want to make sure we take care of those customers. We make them happy. Maybe they come back to something different. So yeah, we're very open to contract process.
On a related question from one of the attendees, do you only process hops from the local area or from other areas like Europe?
We do European hops. We will bring in a certain portion of them as bales, and we will process them here. Some of it is a timing issue, and it's also with logistics. It's more cost effective to bring over finished goods. Something like the New Zealand and Australian hops, we do not process those. It happens 6 months apart. And one thing that could really create a mess is trying to process hops in 110 degrees. And that's what it is here when the New Zealand hops, will come off. And so we do not process in the southern hemisphere. But yes, we will process some of our European hops. It's a timing issue for customer requests. We've had customers request that we process their hops. We want our hops, not the German or UK or the Czech Republic.
Sounds good. Yeah, it's getting hard to hear you again. So just for the audience to be able to hear clearly, do you mix varieties for brewers?
We mix varieties for our hop solution blend. I hope everybody's heard about the 5 blends. Right? Obviously, the hop solution blend has basically what's in them, but there's some different styles here. There's everybody that just or we mix varieties for a customer.
Much better, much better. Thank you.
Yeah, I'm sorry. In walking, Mike got slid to the back.
No,
so the short answer is yes, we will mix varieties for customers. The longer answer is we would have to sit down and really have an agreement. Because once we have a customer that comes in and says, hey, I use 30% Cascade, 20% Cashmere, and the rest, a CTZ, and that's what I need. Well, that's all great. We would love to do that. But once we do that, that hop is only good for that specific customer.
Yeah.
So there are some things that would have to be talked about. We're very willing to do it. Like I say, we do it in our hop solution blends, but those are marketed, to everybody. But for our customers, they just have to sit down with their salesperson and make sure that we're guaranteed that those hops are going to leave here and we're going to get paid for them once we mix them, because they really won't be good for anybody else other than that specific customer.
that makes sense. So I have 2 questions I'm going to combine. They're both related to the processing and the plant specifically. Is your processing seasonal or continuous every day or week? And how many people are required to man the entire production cycle?
Sure, that's a good question. We have a very short production season, so I'm going to leave the warehouse. And just a little side note, these are the guys receiving bales in, a lot of tests they have to do. They have to weigh every bale, get them tagged up. But back to your question, this is a very seasonal operation as processing. Receiving starts at the end of August, stretches through September. We're right at the tail end of it. We try and start processing first full week in October. But our commitment is to get all of our domestic hops done by December 31st. So I haven't always been at this company. I was at another hop company. And I was always concerned when customers would come in and select hops in September, yet they wouldn't be until ceremony, because they may not be bad, but the profiles have changed to the point, is this really what they select? And so my commitment to BSG or through BSG for our customers is I'm going to design a machine that has the capability to run whatever we have and get it done by December 31st. That's a 3-month window. Last year, we beat it by a couple of weeks. We had a great season. And if we ever get to the point we are processing into January on somebody's domestic hops, that's the time we need to put in a second line and make that commitment to shorten that season again.
Yeah.
So that's actually, I'm glad somebody brought that up because that is a great question. I love talking about that.
And then, so what happens to the machines? A follow-up question, do they have a year-round cycle or are they on a partial work basis?
Yeah, so we have some other operations. We do rebagging that keeps some of our people busy.
Good.
A lot of the people that we have out here are going to be temporary staff just for that season. They're going to be let go when production is over.
Mhm.
But the machine, it actually takes 2 to 3 months for us to tear it down with our small crew. We're very lean. Get it cleaned up because we don't use any solvents, cleaners. Everything is scraped. And then put it back together and get it ready for the next season. We don't do any other products at this point. I know some other processors may be doing hemp, which is great. It keeps them busy, but they have larger crews that they can keep on staff. I don't.
Yeah.
We're here to process hops.
Couple of pellet mill questions if you've got in our last 1 minute. So who manufactures pellet mills and how do you clean the pellet mill?
So the pellet mill, cleaning the pellet mill, I'll start with that, is just like anything else on this machine. It's be with your hands and scrapers. Then they're covered with plastic for the season. We leave the corn inside as much as we can.
Water?
No water.
Nothing.
No water.
Yep.
No. This is all food grade machinery. Anywhere water can pool, you've
Yep.
got the chance of really, having something nasty. So everything is dry. If we need water, it's disassembled, take it outside. We use a steam pressure washer to clean it, and then allow it to dry before we bring it back in. And sorry, there's one more part of that question. Trying to think of what it was.
Pellet mills. Some
Oh.
manufacturers, yeah.
Yeah, there's a few of them. We choose California Pellet Mill. It's a direct drive, shaft drive. We like that. I've used their machines for many years. I really like them. Yeah, you look at all this equipment. Let's see, one piece, the Bale Breaker that we first started with is the only machine on this system made specifically for hops. Hops is not a huge industry. Maybe there's a dozen processors that I can name off. That's not a big enough industry to actually make machines specifically for that product. So everything we use here is used for other products. California Pellet Mill, they also supply our hammer mills. Good quality product, but everything else is pieced together. You know what you need. It's used in other industries, so you find out what's best for hops. And no matter what you buy, adjustments have to be made for hops because hops are always different. They're sticky.
Shane, I was just
Go
going to say at the top of the hour, so if you could flip your phone and just give the audience a send off here. We just wanted to thank you for taking an hour or more out of your. I know this is a very busy time for you, and just that you manage.
Always willing to do tours. Fortunately, with COVID, I've missed out on my last 2 years, which is about 200 tours. So to do one live in a webinar that's like a vacation for me. So
well, it's our pleasure, and all of our participants today. We appreciate you and everything that you're doing there. And thank you to all of the participants who joined us today. This was really a great education onto the facility. So with that, we're going to sign off and say happy brewing and enjoy the rest of the hop season. And good luck, Shane. Thanks so much.
all right, cheers.
Cheers to you.